So, shall we start?
Yes, please.
Yes. Good afternoon, everyone. With great pleasure, I extend a warm and respectful welcome to our esteemed Principal Madam, Dr. Sangeeta Joshi, whose vision and commitment continue to inspire innovation and academic excellence at VIT. Warm welcome, ma'am. I also warmly
Thank you.
welcome I also warmly welcome head of the departments, distinguished faculty members, and all the enthusiastic second year students gathered here today. Dear students, as you step into the second year of your engineering journey, you're also stepping into a phase where your academic choices begin to shape your professional identity. Today's session is designed to introduce you to an exciting opportunity provided under the multidisciplinary learning framework, an opportunity to explore a domain beyond your core branch of engineering, develop new competencies, and prepare yourself for the rapidly evolving professional world. These multidisciplinary courses allow you to gain knowledge in emerging and diverse fields, helping you build a broader perspective, enhance employability, and become industry ready professionals. Through this orientation, you will get an overview of the five specializations that are being offered and understand how each of them can contribute to your academic and career aspirations. I encourage all of you to listen carefully, ask questions, and make an informed choice based on your interest, strength, and future goals. With that, let us begin today's orientation program. I now request our Principal Madam, Dr. Sangeeta Joshi ma'am, to speak a few words.
Thank you, Akshada. A very warm welcome to one and all my first year engineering students who are now going to the second year, and all my colleagues to this multidisciplinary orientation program. All of you must have been excited to go to your respective departments. And this multidisciplinary is the concept which is launched in the National Education Policy 2020 in order to have a extensive interdisciplinary knowledge. So that is the basic idea, so that you can build interdisciplinary projects, and that knowledge is anyway required for enhancing employability also, and even for all your project ventures also. So keeping that in mind, VIT has launched five tracks under this multidisciplinary courses. And I think this is one of the features of the VIT's curriculum, which is really beautiful in the sense that students are getting the flexibility of choices. If you go to the any other institutes, you probably may not get so much of choices. Only specific subjects are being given, and you are told to undergo that subject. I mean, that is made mandatory. Here, what we have done is that we are having a five tracks for the multidisciplinary courses. I'll just let you know the titles. The first track is bioinformatics, which is applicable to all the students. Second is robotics, which is applicable to all the students except biomedical engineering. Then the third is innovation, entrepreneurial, and venture development, and this is applicable to the all program students. Fourth is marketing and finance, business development, marketing, and finance. For this also, all program students are eligible to opt for. And the last one is the computer science, which is applicable only for biomedical engineering and electronics and telecommunication engineering. Because for other branches like computer, IT, and electronics and computer science, whatever the courses are there in the computer science, these are already covered in their curriculum. So that is how they are not made eligible. There is no other reason And robotics also, since biomedical is already having in their curriculum, that is not there. So, you please listen to all the experts very thoroughly. Whatever your doubts are there, clear those doubts. And professors would be telling you the details about the courses. Normally, these tracks now it is starting from the semester 3. So, there are three courses in the semester 3, 1, semester 4, 1, and semester 5, 1. And each course is of, I think, 4 credits, 3 plus 1, 3 theory and 1 tutorial or lab course. And so like this, these are the 12 credits plus there are 2 credits which are again splitted into the 1 plus 1 credit. So out of those 2 credits, the first credit is in the semester 4. So there is a one credit course, professional competency development 1, and another 1 credit course which is professional competency development 2. That is in the semester 5. So in the semester 3, there are 4 credits of MDM. Semester 4, there are 5 credits, 4 credits course and 1 credit this professional competency development. And in the fifth credit also, 1 course and 1 credit, 1 course of 4 credit and 1 credit for the professional competency development course 2. This professional competency development course is recently designed, and this is currently also applicable to the semester, I think, 5 and semester 7. Basically, what we have kept in mind while designing the curriculum is that to enhance the employability of the students' placement as well as to have the interdisciplinary knowledge and IT sector knowledge. So, accordingly, the design is there. Our professors will let you know all the details of the syllabus as well as the credit structure as well as the contents. And based on that, you please make the choices. And whatever you are learning here, I mean, in the VIT curriculum is definitely very good and very enriched curriculum is there. And deployment, I mean, content delivery, our faculties are also doing it very nicely. I mean, dedicated and passionate faculty is the strength of Vidyalankar, and that you have all experienced during the first year. And of course, assessment methodology also is very genuinely designed for each course based on the nature of the course. So with this, I thank you, Akshada, and the organizing team for giving me an opportunity to speak to all the students. I hand it over to Akshada. Thank you.
Thank you so much, ma'am, for sharing the opening remarks. I now request Dr. Mandar Sohani sir, faculty from the Computer Science Department and Accuracy Director, to address the gathering. Mandar sir, over to you.
Hello, am I
Hello.
audible?
Yes, sir, you're audible.
Yeah. Very good afternoon to everyone. Respected Principal Madam, respected Head of the Departments and Domain Experts, my dear colleagues and dear students. Uh, it seems it seems that now this introduction becomes little redundant after the opening remarks of the Principal Madam and the welcome speech by Akshata Madam. But I will try to cut short it and give you little philosophy behind the multidisciplinary minor courses. It gives me immense pleasure to welcome you all to this orientation session on multidisciplinary minor courses. Engineering education has traditionally focused on developing strong technical knowledge and professional competence. However, in today's rapidly evolving world, success requires much more than expertise in a single discipline. Professionals are expected to work across domains, adapt to emerging technologies, communicate effectively, and understand the broader social and business context of their work. One of the most significant advantage of multidisciplinary minor courses is that they provide students with an opportunity to learn subjects of their personal interest beyond the compulsory courses prescribed in their curriculum. While the major program ensures depth in a chosen engineering discipline, minor courses offer the freedom to explore areas that align with individual passions, career aspirations, and emerging industry requirements. Whether it is bioinformatics, robotics, innovation, entrepreneurial and venture development, business development, marketing and finance, or it is computer science, students can pursue learning that excites and motivates them. I encourage all of you to view these minor courses not merely as additional academic credits, but as opportunities for self discovery, intellectual growth, and career enhancement. The choices you make today may open doors to new interests, new skills, and new possibilities for your future. Remember, your major degree defines your specialization, but your minor can help you define your uniqueness. The philosophy of multidisciplinary minor courses is rooted in the belief that complex real world problems cannot be solved through expertise in a single discipline alone. Modern professionals need a blend of technical knowledge, human understanding, creativity, communication, and analytical skills to thrive in an interconnected world. Key philosophical foundations behind introduction of MDM as a part of the curriculum is as follows. Holistic development of learners. Minor courses enable students to develop beyond the boundaries of their major discipline. They nurture intellectual curiosity, broaden perspectives, and promote lifelong learning. Second, integration of knowledge. Innovation often emerges at the intersection of the disciplines. Multidisciplinary minors encourage students to connect concepts from different fields and apply them creatively to solve practical problems. Third, enhanced employability. Industries increasingly seek professionals who possess diverse competencies. A student of engineering with a minor in management, finance, automation, etc., can contribute more effectively in multidisciplinary teams. Fourth, flexibility and personalization. Minor programs provide students the freedom to pursue their interests, passions, and career aspirations without changing their primary degree program. This promotes learner centric education. Fifth, preparation for future challenges. Global challenges such as climate change, sustainable development, healthcare, artificial intelligence, and smart cities require knowledge from multiple domains. Multidisciplinary learning prepares graduates to address such complex issues. Sixth, development of transferable skills. Minor courses strengthen critical thinking, problem solving, communication, collaboration, leadership, and ethical decision making skills that are applicable across professions. And last but not the least, alignment with the NEP 2020. The multidisciplinary approach is strongly advocated by the National Education Policy 2020, which emphasizes flexibility, academic mobility, and creation of well-rounded graduates capable of contributing to society and the economy. Multidisciplinary minor courses are designed to transform students from specialists with narrow expertise into versatile professionals with broad perspectives, enabling them to innovate, adapt, and lead in an increasingly complex and interconnected world. With this, I would like to conclude my introductory remarks. Thank you, and I wish you all the very best in your academic journey. Over to you, Akshata Madam.
Hello, Akshata ma'am.
Am I audible?
Yes, yes.
Okay, so can I, there is some
You're not clearly audible, Akshata madam.
there is echo. So should I leave and join again?
Please, Sunil, zara about.
Yes, sir. Yes, sir.
Good afternoon. There's some
Good afternoon, ma'am.
there's echo. Should I don't know.
Pushpa, ma'am.
There is an echo.
Yeah.
Yeah, yeah, yeah. Am I audible? There's still
Uh, Pushpa, ma'am.
yes.
Yeah, you're audible now. There is a slight echo from your end.
Yes, there's echo. So what should I join again? In left and join again.
There might be two devices on. Make one device mute so that echo will not come.
So I mean the device will be there, but I close and join again. Just give me a second.
Hello, Pushpa ma'am.
Madam will be joining in a minute. Pushpa, ma'am. Hello, Pushpa, ma'am.
Yes. Am I audible
Yes.
now properly?
Yes, you're audible, ma'am. Yes.
Guys, share my PPT from my device. Okay, so PPT is visible now. Okay, so I'll start. Good afternoon, everyone. I'm Dr. Pushpa Mahapatro, Associate Professor at Vidyalankar, and I'm going to explain about what is bioinformatics. So bioinformatics, we can decode it as biology, computer science, AI, data science, whatever domain we are in, whether it's computer science or information technology or maybe biomedical. We are going to learn about bioinformatics because it's a different domain. So I would like to show one small video on bioinformatics. Ma'am, please play the video.
Pushpa ma'am. Hello, Pushpa ma'am. Pushpa ma'am, am I audible?
Yes, ma'am.
Ma'am, can you please share the PPT from your end?
That's what I said. I will share it from my end.
Yes.
But I am disabled, host disabled. Attendee screen sharing. Screen sharing is disabled.
Just a second, ma'am.
Now check, ma'am.
Yes, allowed. I hope my PPT is visible.
Yes, ma'am, it's visible.
Okay, so I'll start. Good afternoon, everyone. I am Dr. Pushpa Mahapatro, Associate Professor in Vidyalankar. So we are going to talk about bioinformatics, where biology meets the computer science, biotechnology, and information technology. So what is bioinformatics and why we should learn bioinformatics? That's the first question that comes in the mind of students. So it's basically we are trying to combine biology with technology. So that's why we say it's bioinformatics. So I'll show you one video on bioinformatics. It's a animated video with music. So please watch the video.
In today's world, where advancements in biological sciences and technology have brought about an explosion of data, the field of bioinformatics has become essential. Bioinformatics combines biology and computer science to unlock the secrets hidden within the vast amounts of biological information. In this video, we will provide an introduction to the fascinating world of bioinformatics. Imagine having a puzzle with billions of pieces, where each piece represents a fragment of DNA. Bioinformatics helps us assemble and decipher this puzzle by utilizing computational tools and techniques. At the core of bioinformatics lies the study of DNA, the blueprint of life. DNA sequences encode genetic information, and analyzing them allows us to understand various aspects of biology, such as the functions of genes, the relationships between species, and the causes of diseases. Bioinformatics utilizes algorithms and statistical methods to analyze DNA sequences. These algorithms can identify genes within sequences, predict their functions, and compare sequences from different organisms to understand their evolutionary relationships. Proteins are another vital component of life, performing various functions within cells. Bioinformatics also plays a crucial role in understanding protein structure and function. By analyzing protein sequences and structures, we can predict their functions, discover potential drug targets, and design new drugs. This knowledge aids in developing treatments for diseases and improving our understanding of how living organisms work. Gene expression data reveals which genes are active in different tissues or under specific conditions. Bioinformatics helps make sense of this data to uncover patterns and understand gene regulation. With bioinformatics, we can analyze gene expression patterns to understand how genes are regulated, identify genes associated with diseases, and even predict the outcome of certain treatments. Bioinformatics also plays a crucial role in genomics research. Genome-wide association studies, GWAS, involve analyzing large data sets to identify genetic variations associated with diseases or traits. By applying bioinformatics techniques to GWAS data, we can pinpoint genetic variations that contribute to diseases, such as cancer, diabetes, and cardiovascular disorders. This knowledge provides valuable insights into disease mechanisms and potential therapeutic targets. Bioinformatics is an ever-evolving field, driven by the continuous advancements in biology, computer science, and data analysis. Its applications are vast, ranging from understanding the fundamental principles of life to developing personalized medicine.
Okay, so I hope you all watched the video carefully. So the question comes is why bioinformatics matters to us, because we are all humans. We are having DNA. So to understand the DNA, protein, genome sequences, so that we'll be able to understand the diseases better. We'll be able to get some insights into the healthcare. So we can use this bioinformatics. So we can apply it for drug discovery, genomics, vaccine, personalized medicine, for agriculture, which type of crop can be brought into for the next, so that the diseases can be avoided. So many things we can do research on. So which are the industries that are relevant? One is healthcare, then pharma, biotechnology, AI, data science industries. All these use the knowledge of bioinformatics. So I'm just giving you an overview of what are the career opportunities. You can become a bioinformatics analyst, computational biologist, AI, healthcare engineer. Now, in future, you can go for medicines, healthcare data, genomics, AI, drug design, because see, many diseases are coming. So we need to understand that what are the difference between the different mutations, and because of which the diseases, their symptoms and everything is changing, and then what is the cause, what is the cure for these diseases. Okay, so there are basically 3 subjects, as it was told by the HOD, that we will be having 3 subjects, one in SEM 3, SEM 4 and SEM 5. Okay, so in SEM 3, we are going to learn Introduction to Bioinformatics. Basically, in this subject, you will be having the introductory part where you will be understanding the DNA, RNA and protein structure. You will be understanding that what are the different databases that are already created and available, and what is the difference between these data sources. So we are already having databases provided by different websites, like NCBI is there. So they are providing all the DNA structure and genome sequences for free. You can download those sequences, and how you can study those sequences, analyze those sequences, that we are going to learn in the introductory chapter, that is Introduction to Bioinformatics. We call it as MDM BI01. Then in the subsequent, you will be having data structures in bioinformatics. So in the data structures, we are going to learn about the basic data structures with which we will be handling this large amount of data, because the genome sequence is very large. And then like you will be having the arrays, tree, graph, hashing and other things will be there to solve these computational problems. And then you will be trying to analyze how we can compare different algorithm for DNA, RNA, and protein sequence analysis. What is mean by global, local, alignment and all. And then you can also create the phylogenetic tree. You can find out the distance between the different genome sequences, and you can find out that if suppose there is a mutation of a particular disease, so what is the distance between the two sequences. You can take two sequences, you can do the comparison, you can nucleotide by nucleotide, and then you can identify what's the distance between the two mutations of the same DNA. And then in the third subject, that will be in your TY, you will be learning machine learning applications in bioinformatics. So in this, first the AI, machine learning, then deep learning, then disease prediction, drug discovery, and all this, and how it will be implemented in machine learning, that you are going to learn. So basically, all the subjects, like how you will be downloading the data set from the freely available data sources, and then how you're going to apply the different algorithms. So in the first will be your introductory, second chapter will be the data structures for storing all this and analyzing the sequence, and then in the third you are going to learn the machine learning, how you will apply machine learning on these sequences. So I hope these three linkages are clear to you. And the skills that you are going to develop, of course, Python is the basic language in which we are going to do the programming. So you will be learning Python, you will be learning the different libraries with which we can actually compare the genome sequences, we can actually perform the AI ML operations on the data. Then of course, many mini projects you can develop. So I have just put a few examples, like suppose cancer prediction, DNA analysis, protein prediction, medical imaging. So all these different types of mini projects you can work on. You can actually work on various research papers on bioinformatics, because for every disease, for every mutation, say if you take the example of coronavirus, so every mutation of coronavirus is different. So what's the difference, what is the distance between the two genome sequences, you can find out. So of course, if you want, you can go for higher studies like MS, MTech, PhD in bioinformatics, computational biology, and AI. And so why you should choose bioinformatics? First is, if you are interested in biology, means in 12th standard I was having biology, so I was interested in biology, but that is a completely different domain. But I was not knowing till the I entered into bioinformatics, that actually the biological problems we can solve with the help of technology. So if anyone is having interest in biology, and at the same time they also want to know that how we can solve these problems with the help of technology, then you must take the bioinformatics track. Okay, so this benefits. One is, it is interdisciplinary, learning will happen, because again it will not be similar like your regular subjects. You will be learning something different, something apart from the domain, but at the same time you will be able to recall the knowledge that you have gained in your 12th standard biology. And then of course employability, because now there are many new diseases that are coming up, even many mutations of the same diseases are there, then we are having various fields where we can employ. So employability is there, research exposure we are getting. In the emerging trends in biotechnology is like, we can go for digital biology, multi-omics, then AI scientist, and precision healthcare. So thank you all. If you have any questions, doubts, you can ask in the chat, or you can unmute and ask.
Any questions, dear students? Yeah. So if you have any questions, request you to please put it in the chat box. We will take up the questions in the end. Thank you so much, Pushpa ma'am, for such a comprehensive overview of the program. We now have Dr. Aarti Kane ma'am from Biomedical Department to orient the track robotics. Aarti ma'am?
Yeah, yes. Yeah. Am I audible?
Yes, ma'am, you're audible.
Yeah. So, good afternoon, everyone.
Good afternoon, ma'am. Ma'am, do you want me to share the slide?
The slides are with me.
Okay, ma'am, fine.
These are updated slides. So, shall I share my PPT?
Sure, ma'am, yes.
Yeah. Is it visible?
Yes, ma'am.
Okay. So, today I would like to present the multidisciplinary minor track in robotics. We are living in the era where intelligent machine, automation, artificial intelligence, and autonomous systems are transforming every industry. So this minor track is designed to provide the students to gain the interdisciplinary skills that are highly valued by industry. Over 3 semesters, students will learn how robots move, how they perceive the environment, and how they navigate automatically. So this slide summarizes the complete learning journey for 3 semesters. So you will experience this journey in this track. So every intelligent robot, it follows 5 major stages. First, we design the robot and understand its structure and functionality. Then we build the models and develop the algorithms that control its behavior. After that, the robot must perceive the environment through the sensors and cameras. Next, it should navigate by deciding where to move and how to avoid the obstacles. And finally, automation enables the robot to perform the task without continuous human intervention. So, in this track, you will learn all these processes. So many students think that robotics is all about the industrial robotic arm, but in reality, robotics is everywhere. In industries, robots perform different industrial applications such as welding, painting, for the improvement of the productivity, precision, and safety. In healthcare, robots assist the surgeon during the complex operations. In prosthetic devices, make individuals to regain the mobility and independence. Then remote handling robots are used in hazardous environment where human intervention is risky. So these are the different real life applications of the robot. The goal of this minor is to help you to understand the technologies behind these applications. So why to select this robotic track? So the answer lies in the interdisciplinary nature of the robotics. Robotics is one of the few fields that combine the concepts from the computer engineering, electronics, artificial intelligence, automation, control systems. So the world is moving towards the Industry 5.0, where the intelligent machines work alongside human. So robotics are transforming manufacturing, healthcare, agriculture, autonomous transportation, and space exploration. So companies today require the engineers who understand automation, artificial intelligence, data analytics, control system, and robotics. So the global robotic market is growing rapidly and it is creating significant career opportunities. So by learning robotic concepts, you will prepare yourself for the future technologies and emerging job roles. So the structure of this minor subject is planned in such a way that in the first semester, you will learn the robotic motion and control. The second semester is focused on the perception and the machine vision. Third semester, it focuses on the intelligent navigation automation systems. So this progression mirrors that how modern robotic systems are developed from movement to perception and finally to intelligent decision-making systems. So let us understand the roadmap of this journey. In semester 3, it introduces robot kinematics, dynamics, then control system and robotic process automation, that is RPA. Then in semester 4, it introduces the image processing, computer vision, that enables robot to understand the visual information or environment surrounding the robot. In semester 5, it focuses on localization, navigation, mapping. It is used in the autonomous vehicles and mobile robots. So by end of this track, students will understand how intelligent autonomous robotic systems are designed and implemented. So this minor develops both the technical and professional skills. So technical skills include MATLAB programming, Python programming, then robotic concepts, control system concepts, automation, computer vision, and mobile robotics. Whereas professional skills include problem solving, design thinking, project development, teamwork, and system integration. The future of the robotics and the intelligent automation is extremely promising. Students completing this track can explore the opportunities in diverse fields such as manufacturing, healthcare, automotive, aerospace, logistics, defense, smart infrastructure, and research organization. So potential career path includes the automation engineer, then autonomous system developer, control system engineer, embedded engineer. Beyond traditional engineering roles, robotics knowledge is increasingly valuable in emerging fields. For students, those who are interested in higher education and research, this track provides a strong academic foundation. The concepts covered in the robotics are closely connected with the advanced areas such as medical robots, then human-robot interaction, autonomous vehicles, AI robotics. Students can pursue MTech, MS, and PhD programs in AI, mechatronics, autonomous systems, intelligent systems at leading institutions in India and abroad. So one of the major strengths of this track is its alignment with the current industry requirements. Modern industries are looking for the engineers who can understand the automation systems, intelligent decision-making processes, machine perception, and autonomous operations. The concepts covered in this track directly support these industry needs. The knowledge gained through this track will help the students understand the real-world engineering challenges and prepare them for internships, industry projects, innovation competitions, professional careers in technology-driven organizations. So, as I conclude, I would like to leave one quote that the future will not simply belong to the machines, the future will belong to the engineers who will understand the machine, who will design, control, and integrate them. So if you are interested in emerging technologies, innovation, automation, then the robotics multidisciplinary minor track can be excellent choice for your academic and professional journey. So I encourage each of you to explore this opportunity and become part of the next generation of engineers shaping the future of technology. So your minor degree defines your discipline, but this major degree defines this discipline, but this minor specialization, it will define your additional strength and competitive advantage. So with this, I would like to conclude my presentation. Thank you for your attention. If you have any questions, you can put it in the chat box. So thank you. Over to you, Akshata ma'am.
Thank you so much, ma'am. Thank you for the briefing. We now have Mr. Aftab Khan, industry expert from Fortune Technologies, to orient the track innovation, entrepreneurial, and venture development. Over to you, sir.
A very good afternoon, everyone. I hope I'm audible.
Yes, sir, you're audible.
Perfect. Give me a second. Is the screen visible?
Yes.
Okay. Okay. So a very good afternoon, everyone. And a big thank you to everyone for inviting me. And a quick appreciation to all the speakers before me, especially Pushpa ma'am for that session on bioinformatics. So here's the thing. What Pushpa ma'am just walked through is exactly where my track begins to get interesting. So bioinformatics, as we know, it processes DNA sequences. That data moves through software. This we all know. So in 2017, researchers at the University of Washington synthesized a physical strand of DNA, just 176 base pairs, and encoded malicious code into it. Since I'm from cybersecurity, that's why I'm emphasizing on this. So this is very interesting. When that DNA was fed into sequencing software, it triggered a buffer overflow attack. The attacker got remote access to the machine, no network breach, no phishing link. The attack came through biology. And that is a cybersecurity problem hiding inside a bioinformatics pipeline. And that's exactly what the innovation, entrepreneurial, and venture development track is about. The threats are not always there, you expect them. So let's talk about how this track prepares you to think that way. I'm Aftab Khan. I run a cybersecurity company called Fortrum Technologies, and I am a visiting faculty at VIT. I'm not an academic who has read about startups. I've actually gone through the process of building one and currently in the process of building another one. And I'm still in it. So, whatever I share with you today is from that experience. Today, I'm here to talk to you about one of the MDM minor tracks you can choose, which is innovation, entrepreneurial, and venture development. So, most of you are here to become engineers. That's correct. This track is not asking you to pivot into a startup, it's asking you a different question. What if you understood why things succeed or fail? So when I started Fortrum after coming back from the UK, so I did a master's in cybersecurity management from the UK. And when I came back and started Fortrum Technology, I had the technical skills, being a computer engineer myself. What I had to learn on the job was everything else, how to explain what I do to someone who isn't technical, how to price my services, how to convince someone to trust a new company. The World Economic Forum latest jobs uh, report says the most valued skills going forward are analytical thinking, creative thinking, and AI literacy. Not just coding, not just marks. India has over 2 lakh DPIIT recognized startups right now. Every single one of those needs engineers who understand the business side. Not all of them need you to be the founder. This track helps you think like someone who builds useful things, not just assigned things. There's a difference, and it shows up in interviews, in your work, and in how you approach problems. Moving on to the next slide. Uh, the track has 3 courses. You start with MDM IE01, hopefully in the coming semester. That's the one you'd be signing up for right now. So MDM IE01 Foundation, this is where it begins. You learn what innovation actually means, not in a textbook way, but in a practical way. What types of innovation exist, how to generate ideas using proper frameworks, how to use the business model canvas, how to find out whether your idea is even worth pursuing, and how the important ecosystem, how the startup ecosystem in India actually works. It can be incubators, accelerator programs, government schemes, etc. By the end of this course, you will have tried to pitch something. That experience is useful regardless of whether you ever start a company. Okay. And the second one, it's startup planning and development. I taught this course last semester, and I tell you what I saw. Students who were purely technical, no business background at all, built pitch decks that were genuinely good. not because they became founders, but because they finally understood how to explain what they were building and why someone should care. And the third one, which is hopefully I'll be taking this as well. So this one comes later, which is called MDM-03, Information Management and Scaling. Higher semesters, by then you'll know how to build something. Agile teams, growth hacking, strategic partnerships, how AI is being used inside startups right now, and responsible innovation and other things. So you start with an idea, then you learn how to plan it, then you learn how to scale it. It's as simple as that. And what skills will you build? Look at this grid. Some of these are technical adjacent, MVP mindset, market analysis, product thinking. Some are softer, like communication, pitching, customer understanding. All of them are things that show up in the real world. The one I want to highlight specifically is the AI enabled innovation mindset. AI is changing how startups operate. You don't need to build the AI, but you need to know how to think about using it, building with it, and competing in a world where it exists. That's what MDMIE03 gets into. So these skills are useful whether you end up at a large MNC, a startup, consulting, research, or if you eventually build your own thing. They add a layer that most engineers don't have, and that's noticeable. Okay. Quick question before we look at this particular slide. Do you think this track is only for students who want to become CEOs or start a company? You can reply in the chat. And the answer is no. Startup thinking is useful for an engineer, a product manager, a consultant, a researcher, a freelancer, or someone joining a family business. What changes is how you think about problems, and that affects everything. If you are curious about startups, obviously this is for you. But also, if you want to understand how products are built and why some succeed and others don't, if you're thinking about an MBA or management later, this track gives you real material to draw on. If you have a family business and want to understand how to think about growth and strategy, there are direct applications over here. So I'll give you a student story. In last semester, I had students who came in and saying, I'm a tech person, I don't do business. But by the end, they had built pitch decks and presented them in front of a simulated investor session. Not all of them wanted to start companies, but all of them left with a clearer sense of how to explain what they build and why it matters. That's the shift. And one of the teams, they got funding, actual funding from one of the places where they have presented. So, if you want a track that connects technology, creativity, business, AI, and real world problem solving, this is a strong choice. You don't need to know everything today. The track is designed to take you step by step from foundations to planning to scaling. You don't need a startup idea today. You only need curiosity. And that's it from my part. Thank you so much. If you have any questions, please feel free to paste it in the chat box.
Any questions, dear students? Thank you so much, Aftab sir, for the valuable insights.
Thank you, ma'am. My pleasure.
Thank you, thank you. We now have Dr. Dattatreya Bade sir and Professor Sukant Rana sir to orient the track Business Development, Marketing and Finance.
Thank you, ma'am.
Thank you, sir.
Okay, I welcome all AC students for the MDM courses. So EXTC department is offering business development, marketing, and finance. So as already principal ma'am also told that this is a 14 credit courses. So every semester there will be, for consecutive 3 semesters, there will be a MDM course of 4 credits, 3 plus 1. So the first course in semester 3 is Introduction to Business Development and Marketing Principles. In semester 4, financial basics for engineers and technopreneurs. In semester 5, subject is a strategic marketing and business planning. So there will be total 12 credits. And in semester 6 and 7, there will be 1 credit professional competency development, 3 and 4 respectively. So this is for the business development, marketing and finance MDM course. Now I request Professor Sukant Rana sir to explore and give the importance of this MDM in more detail.
Good afternoon everyone. Am I audible?
Yes sir, you are audible sir.
Yeah, good afternoon, specifically good afternoon students. A very warm welcome to all of you. Today I would like to share a simple but powerful truth. The future will not belong merely to those who can build technology. It will belong to those who can create value from technology. That is, we will have a journey from engineers to innovators, leaders, and wealth creators. For decades, engineering education focused primarily on developing technical expertise. Engineers designed circuits, built machines, wrote code, and developed products. But the world has changed. Today, artificial intelligence can write code, automated systems can perform calculations, machines can assist in design. So what will distinguish the leaders of tomorrow from everyone else? The answer is very clear. The ability to understand customers, markets, money, business models, and strategy. The next generation of successful engineers will not only know how technology works, they will know how customers need it, why customers need it, how to market it, how to finance it, how to scale it, how to build businesses around it. That is precisely why the multidisciplinary minor in business development, marketing, and finance is so important. This minor has been thoughtfully designed to transform engineering students into future-ready professionals. Let me briefly explain how. The first course, which is Introduction to Business Development and Marketing Principles. Many brilliant technologies have failed, not because they are technically weak, but because nobody understands why customers should buy them. History is filled with examples of superior technologies that disappeared because their creators failed to understand the market. This course teaches you something that every entrepreneur, innovator, and corporate leader must master, which is understanding people. You will learn how businesses are built, how markets function, how customer needs are identified, how products are positioned, how opportunities are discovered. Imagine developing an innovative telecom device, a smart healthcare solution, or an AI-powered platform. Technical knowledge helps you build it, but business development and marketing help you ensure that people actually use it. This course trains you to think beyond the laboratory and begin viewing technology through the eyes of the customer. In a world overflowing with innovation, understanding customers is no longer optional. It is a competitive advantage. The second course, which reads Financial Basics for Engineers and Technopreneurs. Let me ask you a question. If you design a brilliant product but cannot determine whether it will be making money, have you truly completed the project? The answer is no. Every engineering decision ultimately has a financial consequence. Whether you work in a multinational corporation, launch a startup, manage projects, or lead a business unit, financial literacy becomes essential. This course brings you budgeting, cost analysis, financial statements, project evaluation, funding mechanisms, investment decision makings. You will also learn concepts such as break-even analysis, return on investments, net present value, sources of startup funding. These are not merely financial terms. These are the tools used by CEOs, investors, entrepreneurs, and business leaders every day. The engineer who understands finance speaks the language of decision makers. The engineer who understands finance rises faster into leadership positions. The entrepreneur who understands finance dramatically improves the probability of building a successful enterprise. The third course, which is Strategic Marketing and Business Planning. This is also very interesting. Ideas are abundant. Successful execution is rare. This course teaches the art and science of converting ideas into sustainable businesses. You will learn strategic marketing, branding, market entry strategies, customer acquisition, business planning, growth strategies. Consider some of the world's most influential companies. Their success is not merely because of technology. Their success is because they developed strong brands, effective business models, scalable strategies, deep customer understanding. This course teaches exactly those capabilities. You will learn how to think like a founder, a strategist, a business leader. You will discover how products move from concepts to markets and from markets to global success. These are skills that remain valuable regardless of technological changes. Why these courses matter more than ever? We are entering an era where boundaries between engineering, business, and innovation are disappearing. The most successful companies today are founded by people who understand both technology and business. Industry now seeks professionals who can solve technical problems, understand customers, communicate ideas effectively, evaluate financial feasibility, lead multidisciplinary teams, create sustainable value. Employers increasingly prefer engineers who can think commercially. Investors prefer founders who understand markets. Organizations promote leaders who understand business. In other words, technical competence may get you a job, but business competence can help you build a career, lead organizations, and create wealth. So let's focus on the entrepreneurial opportunity. Many of you sitting here today will become engineers, researchers, product managers, startup founders, consultants, business leaders. Some of you may create companies that do not yet exist. Some may develop technologies that solve problems for millions of people. Some may generate employment for thousands. When that moment arrives, dear friends, you will need much more than technical knowledge. You will need vision, marketing insights, financial understanding, strategic thinking. These courses are designed to build precisely those capabilities. A final thought, dear friends. Engineering teaches us how to create solutions. Business teaches us how to create an impact. Finance teaches us how to create sustainability. Strategy teaches us how to create scale. When these four come together, extraordinary things happen. You stop being merely an engineer. You become an innovator. You become a leader. You become a creator of opportunities. You become someone capable of transforming ideas into enterprises and enterprises into lasting value for society. I encourage each one of you to embrace these multidisciplinary opportunities wholeheartedly. The future belongs to those who can combine technology with business insight, innovation with execution, and knowledge with vision. May you not only build great technologies rather, may you build great careers, great organizations, and great future. Thank you all. I wish you an exciting, successful, and transformative journey ahead. Thank you.
Thank you so much, sir, for sharing your thoughts and expertise.
Thank you, ma'am.
I now request Professor Pankaj Manwari, sir, to brief about the computer science track. I request all the other students also to please wait and listen to the presentation. We will be giving the general instructions later. Pankaj,
Thank you very
sir?
much. Yeah, thank you very much, Akshata ma'am. Am I audible?
Yes, sir, you're audible.
Thank you. I'll just yeah. So my presentation is visible to all?
Yes, sir, it's visible.
Yeah.
Yes.
Okay, thank you. So good afternoon all. EXTC and biomedical students, that is those who have taken telecommunication or biomedical technology as their major, will be having the option to simultaneously learn computer science as their minor. So those who really had an affinity to know how computer science is getting used, but do not want to, consider that as your entire career, did not opt for that as a major or might have missed it due to some score related issues and have opted for telecom or biomed. Now is your opportunity that you can learn computer science, although if not as a major, but as a minor. Later on, you can also take it further to pursue honors in any of the applied domains of computer science. And this knowledge will definitely give you an edge over any other students who are not having that stronger computer science background. So here we are basically building the background. So the overall objective, just a minute. I've lost the, it's not moving to the next slide. Yeah. So the objective of this particular entire multidisciplinary minor on computer science is to develop a strong knowledge of computational and problem solving skills. You might have heard about these words slightly during system programming, that is while learning C, or during Java programming when you learned OOP. Uh, Trying to understand it at a more structure and algorithmic level will definitely make you understand stuff like artificial intelligence or machine learning algorithms in a more convenient manner. It will allow you to apply these computational techniques in telecommunication or biomedical domain wherever you are. So any emerging technique like AI or data analytics or IoT or healthcare informatics is where you can explore as your future work. Enhance the employability in by extending your reach from not just confining to your major domain, but also cross domain. That means where you're working in your own core branch as well as applying it with the technologies of recent, which is coming from computer science, such as healthcare informatics has been a very well known buzzword, and data centers who are trying to maintain health records are one such data analytics areas where a lot of students who have pursued biomedical as a major and gone ahead with computer science either as a master's or like you all would have opted for that as a minor. So the first course that you will be learning is computational logic and data structure. And this particular subject will be basically focusing on developing problem solving using algorithms. So here it's not more about the syntax of a language, but it's about how naturally you develop and step by step a problem, or how you break a problem step by step into its solution. And whether it is a prompt engineering or it is a AI tool that is assisting you to develop a program, eventually it's you who have to break a problem into steps before you actually feed it. So how the problem solving skills are to be done for algorithm development or computational thinking will be your key learning area in this subject. Fundamentals of programming logic, linear and non-linear data structures, that is how your information will be organized in your memory. Some basic algorithms like searching sorting, purpose not because you want to do searching sorting, but basically you have to understand keywords like efficiency and complexity of an algorithm. And to introduce you to these words, there will be some basic algorithms like searching sorting that will be introduced. And based on that, you will be introduced to words like algorithm efficiency and complexity. Because whether you are doing in a telecom, working with an embedded system, who demands utilization of memory to be less because they don't want to consume more battery power, or doing a very heavy signal processing, which is computationally so complex that unless you don't break it down, your algorithm efficiency would be really too bad. So for any such domain, these knowledge you can definitely apply. It develops your logical thinking, which would be again required for any communication systems because they are completely controlled by algorithms and computer system. Similarly, biomedical, you have day in and day out, everybody of you all are wearing Fitbit and trying to monitor your health parameters and use your medical data in order to predict some different diseases. All these things definitely require knowledge of basically algorithms and computational thinking. Further, moving ahead, trying to have a knowledge on operating system and computer network, which will give you the exact flavor of why we are so concerned about developing an efficient system, and how can it be made more efficient based on the platform that you're using. Because many decisions are taken based on the platform. What are the processes? What are the memory management techniques that different operating system use? How they schedule the processes, how they allocate resources and deallocate them, because all these knowledge would eventually allow you to handle these systems in a more convenient manner, because you actually understand how fundamentally a system is functioning internally. Similarly, fundamentals of computer network with all the internet protocols. Telecommunication students would be definitely learning 3G, 4G, 5G networking protocols, but that those are all mobile protocols. Similarly, their birth comes from the basic computer protocols, the TCP/IP protocol suite, and along with that, the network security and the system administration basics. So all these things will be quite a direct relevance to the telecommunication, no doubt, can be applied in more advanced techniques like wireless communication. And because security on wireless is definitely a bigger challenge than wired communication, that telecom students would definitely either know it or they will come to know. Understanding such communication protocols and networking architecture would be one more additional benefit to telecom students. Biomedical students will be able to understand embedded systems, that means devices which are communicating with the actual system. You will be able to understand their working better, because operating system and CN tells you about how the platform works, and that gives you clarity of understanding such interconnected medical devices for hospital information system or telemedicine. Lastly, we would be having the third course on databases and data mining. Uh, After all, everything is about handling data, whether it is a communication record, as I don't know, I might be wrong because I'm from computer background. It's called something like CDR record, which is basically a telecom record about your each calls or messages that you're doing. That's a data. For a biomedical student, every CT scan or any MRI being taken as an image is also nothing but a data. So this particular system tells about how the database system works internally and how the mining operations actually are performed on this data. So rather than you using it like a toolbox, as a black box, you will be able to have a clarity of what is happening inside this black box. So these subjects, I would not claim that make you a computer engineer wholesome or completely teaches you domain like data analytics, but definitely gives you an edge over any student opting for honors in or a track of artificial intelligence, machine learning, data science, data analytics, or similar domains. So these are the skills that I just mentioned that you would be learning across computational thinking, programming and algorithm from CLDS, system and network understanding from OSCN, database management, data analytics. Once again, problem solving and decision making, right from CLDS to data mining and interdisciplinary technology integration. Higher opportunities, as I mentioned, not only just AI, ML, data analytics, even smart systems, healthcare informatics, or even if you want to pursue higher studies and get into research in computing applications. So you can see yourself in future working on some biomedical applications or some telecom applications and having a fair understanding of how these systems are actually performing the tasks that you are submitting to them. So the minor in computer science equips telecom and biomedical students with essential computer competencies, enabling them to solve domain-specific problems using modern software, networking, and data-driven technologies. So if you really find this fascinating, you're welcome with us for learning computer science as one of your minors. Thank you. Over to you, Akshita ma'am.
Yeah. Thank you so much, sir, for the comprehensive overview of the program. I now request
Pleasure,
Dr.
ma'am.
Mandar Sohani, sir, to please take over.
Yeah, good afternoon again. Hello.
Good afternoon,
Yes, sir.
sir.
Yes, sir.
You're audible.
You're audible.
Yeah. Yes. Yes. Good afternoon, students, again. I hope you have listened patiently to all the domain experts. And to summarize the things, I am back again. So this particular table will give you a clear picture about what are the options available in front of you when you are entering into third semester of your graduation program, right? So to summarize the things, it is like this. There are overall 5 minor programs offered across the institute. You can see the second column of the table, title of the minor. The 5 programs are listed, which are bioinformatics, computer science, innovation, entrepreneurial and venture development, business development, marketing and finance, and fifth one is robotics. Each one is offered by a different department. So you can ignore first column of this particular table. Who is offering is not important for you. For whom it is applicable or to whom it will be offered, that is important. So column number 2 and column number 3 are important from your point of view. So if you look at bioinformatics, name of the title of the minor is bioinformatics, and this is offered by IT department, and it is applicable to all the other programs, means including IT, the students of IT, computer, EXTC, biomedical, as well as EXES. All students can opt for this particular minor track, whose name is bioinformatics. I hope you have understood that in every track there are 3 courses: one in semester 3, second in semester 4, third in semester 5. Each one is carrying 4 credits, so total 12 credits, and 2 more credits are there. Earlier it was planned as a seminar, but now it is converted into 2 small courses related to the placement related training, that is PCD1 and PCD2, right? So I hope the things are clear. All the students are eligible for enrolling to the minor course on bioinformatics. If you see second row of this particular table, the minor program offered is computer science, which is offered by computer department, and it is not applicable to all. Only the students of electronics and telecommunication engineering and biomedical engineering are eligible to enroll for this particular minor track. Other students cannot enroll for this particular track because, as earlier stated, the courses listed in this particular track are already the core part of that particular program structure, right? The third minor track offered is innovation, entrepreneurial and venture development. This is also applicable for all the branches, all the students. So all the students from computer, IT, EXES, EXTC, as well as biomedical, those who wish to get enrolled to this particular program, minor program, they can enroll for this particular program. And I hope you have understood the 3 courses that you have to complete, which are listed in that particular row. The fourth minor track offered is business development, marketing, and finance. This track is also common. This is also applicable for all the students. So student from any branch can get enrolled for this particular minor track, which is business development, marketing, and finance. And lastly, the fifth minor track offered at VIT is robotics, which is offered by biomedical department, and this is applicable to all the students except the students who are enrolled in the biomedical program. Those who are learning in second year biomedical, they cannot opt for robotics track because the courses mentioned in this particular track are already part of their core curriculum structure, right? So this robotics track is applicable to students of information technology, computer, electronics and telecommunication, and EXES. Biomedical students stay away from this particular track. They are not eligible for enrolling in this particular track. And the last column of this particular table, if you read, the student will be trained as per their specialization on the placement improvement activities, that is PCD1 course and PCD2 course. So earlier it was 2 credits assigned to seminar. Now it is now revised and converted into placement related courses. So you have now got the picture that you have to make a choice between these 5 minor tracks which are available in front of you. And if you are the student from biomedical department, I hope all tracks are applicable to you except robotics. If you are EXTC student, then mostly bioinformatics, then computer science, all tracks are applicable to you. Electronics and telecommunication student, EXES students also are eligible for all tracks except computer science. Computer students are eligible for all tracks except computer science. IT students are eligible for all tracks except for computer science. So this is a summary of whatever we have discussed in this afternoon session. So thank you so much for listening patiently. Over to you, Akshata madam.
Thank you so much, Mandar sir, for detailing regarding the courses. So, dear students, a choice form will be shared with you all in some time. Please read the instructions carefully. The choice form looks like this. So, please read the instructions. This particular choice form will be open till 17th June 2026 midnight. That is Wednesday midnight. You're supposed to enter your roll number, enter your name, the semester, division, and you have to select your branch. So while selecting the branch, please be careful, because once you click the next button over here, यहाँ पे you will be able to see the subjects which are only for your branch. Okay, so please be careful while selecting this particular uh, section, that is select your branch में. So if you choose biomedical, then only those courses which are applicable to you will be visible. Okay, so please be careful while choosing your branch, and then you have to click on the submit button. So you have time till Wednesday to fill this particular choice form. Any questions, dear students? Any questions? As we come to the end of today's orientation program, I extend my sincere gratitude to our principal ma'am, all the speakers, faculty members, and students for their enthusiastic participation. I hope today's session has helped you gain clarity about the multidisciplinary courses and will assist you in making well-informed choice. Thank you everyone. Have a good day.